1. Find the roots of the following quadratic equations by factorization. I, x 3x 10 equals 0. E, 2x plus x6 equals 0. E, square root 2x plus 7x plus 5 square root 2 equals 0. IV, 2x, x plus 1 divided by 8 equals 0. V, 100x 20x plus 1 equals 0. Solutions. I, given, x 3x 10 equals 0. Taking LHS. Equals greater than x 5x plus 2x 10. Equals greater than x 5 plus 2 x 5. Equals greater than x 5 x plus 2. The roots of this equation, x 3x 10 equals 0 are the values of x for which x 5 x plus 2 equals 0. Therefore, x 5 equals 0 or x plus 2 equals 0. Equals greater than x equals 5 or x equals minus 2. E, given, 2x plus x6 equals 0. Taking LHS. Equals greater than 2x plus 4x 3x6. Equals greater than 2x, x plus 2, 3, x plus 2. Equals greater than x plus 2, 2x3. The roots of this equation, 2x plus x6 equals 0 are the values of x for which x plus 2, 2x3 equals 0. Therefore, x plus 2 equals 0 or 2x3 equals 0. Equals greater than x equals minus 2 or x equals 3 halves. E, square root 2x plus 7x plus 5 square root 2 equals 0. Taking LHS. Equals greater than square root 2x plus 5x plus 2x plus 5 square root 2. Equals greater than x, square root 2x plus 5, plus square root 2, square root 2x plus 5, equals square root 2x plus 5, x plus square root 2. The roots of this equation, square root 2x plus 7x plus 5 square root 2 equals 0 are the values of x for which square root 2x plus 5, x plus square root 2 equals 0. Therefore, square root 2x plus 5 equals 0 or x plus square root 2 equals 0. Equals greater than x equals minus 5, square root 2 or x equals square root 2. IV, 2x, x plus 1 divided by 8 equals 0. Taking LHS. Equals 1/8, 16x 8x plus 1. Equals 1/8, 16x4 by minus 4x plus 1. Equals 1/8, 4x, 4x1, minus 1, 4x1. Equals 1/8, 4x1. The roots of this equation, 2x, x plus 1/8 equals 0, are the values of x for which 4x1 equals 0. Therefore, 4x1 equals 0 or 4x1 equals 0. X equals 1/4 or x equals 1/4. V, given, 100x 20x plus 1 equals 0. Taking LHS. Equals 100x 10x 10x plus 1. Equals 10x, 10x1, minus 1, 10x1. Equals 10x1. The roots of this equation, 100x 20x plus 1 equals 0, are the values of x for which 10x1 equals 0. Therefore, 10x1 equals 0 or 10x1 equals 0. X equals 1/10 or X equals 1/10. 2. Solve the problems given in example 1. Represent the following situations mathematically. I, John and Jeevanti together have 45 marbles. Both of them lost 5 marbles each, and the product of the number of marbles they now have is 124. We would like to find out how many marbles they had to start with. E. A cottage industry produces a certain number of toys in a day. The cost of production of each toy, in rupees, was found to be 55 minus the number of toys produced in a day. On a particular day, the total cost of production was 750 rupees. We would like to find out the number of toys produced on that day. Solutions. I. Let us say the number of marbles John has equals X. Therefore, the number of marble Jeevanti has equals 45x. After losing 5 marbles each, number of marbles John has equals x5. Number of marble Jeevanti has equals 45x5 equals 40x. Given that the product of their marbles is 124. Therefore, x5, 40x, equals 124. X 45 x plus 324 equals 0. X 36 x 9 x plus 324 equals 0. X 36 minus 9 x 36 equals 0. X 36 x 9 equals 0. Thus, we can say x 36 equals 0 or x 9 equals 0. X equals 36 or x equals 9. Therefore, if John's marbles equals 36, then Jeevanti's marbles equals 45 minus 36 equals 9. And if John's marbles equals 9, then Jeevanti's marbles equals 45 minus 9 equals 36. E. Let us say the number of toys produced in a day is X. Therefore, cost of production of each toy equals Rs 55x. Given the total cost of production of the toys equals 750 rupees. Therefore, X 55x equals 750. X 55x plus 750 equals 0. X 25 x 30 x plus 750 equals 0. X 25 minus 30 x 25 equals 0. X 25 x 30 equals 0. Thus, either x minus 25 equals 0 or x 30 equals 0. X equals 25 or x equals 30. Hence, the number of toys produced in a day will be either 25 or 30. 3. Find two numbers whose sum is 27 and product is 182. Solution. Let us say the first number is x and the second number is 27x. Therefore, the product of two numbers x 27x equals 182. X 27 x 182 equals 0. X 13 x 14 x plus 182 equals 0. X 13 minus 14 x 13 equals 0. X 13 x minus 14 equals 0. Thus, either x equals minus 13 equals 0 or x 14 equals 0. X equals 13 or x equals 14. Therefore, if first number equals 13, then second number equals 27 minus 13 equals 14. And if first number equals 14, then second number equals 27 minus 14 equals 13. Hence, the numbers are 13 and 14. 4. Find two consecutive positive integers, the sum of whose squares is 365. Solution. Let us say that two consecutive positive integers are x and x plus 1. Therefore, as per the given questions, x plus 1 equals 365. X plus 1 plus 2x equals 365. 2x plus 2x 364 equals 0. X plus x 182 equals 0. X plus 14 x 13 x 182 equals 0. X plus 14 minus 13 x plus 14 equals 0. X plus 14 x 13 equals 0. Thus, either x plus 14 equals 0 or x 13 equals 0. X equals 14 or x equals 13. Since the integers are positive, x can be 13 only. Therefore, x plus 1 equals 13 plus 1 equals 14. Therefore, two consecutive positive integers will be 13 and 14. 5. The altitude of a right triangle is 7 centimeters less than its base. If the hypotenuse is 13 centimeters, find the other two sides. Solution. Let us say the base of the right triangle is x cm. Given, the altitude of right triangle equals x7 cm. From Pythagoras theorem, we know base plus altitude equals hypotenuse. Therefore, x plus x7 equals 13. X plus 49 14 x equals 169. 2x 14 x 120 equals 0. X7 x 60 equals 0. X12 x plus 5 x 60 equals 0. X12 plus 5 x12 equals 0. X12 x plus 5 equals 0. Thus, either x12 equals 0 or x plus 5 equals 0. X equals 12 or x equals 5. Since sides cannot be negative, x can only be 12. Therefore, the base of the given triangle is 12 centimeters, and the altitude of this triangle will be 12 to 7 cm equals 5 centimeters. 6. A cottage industry produces a certain number of pottery articles in a day. It was observed on a particular day that the cost of production of each article, in rupees, was 3 more than twice the number of articles produced on that day. If the total cost of production on that day was 90 rupees, find the number of articles produced and the cost of each article. Solution. Let us say the number of articles produced is x. Therefore, cost of production of each article equals Rs 2x plus 3. Given the total cost of production is 90 rupees. Therefore, x 2x plus 3 equals 90. 2x plus 3x 90 equals 0. 2x plus 15x 12x 90 equals 0. X 2x plus 15 minus 6 2x plus 15 equals 0. 2x plus 15 x 6 equals 0. Thus, either 2x plus 15 equals 0 or x 6 equals 0. X equals minus 15 halves or x equals 6. As the number of articles produced can only be a positive integer, x can only be 6. Hence, The number of articles produced equals 6. Cost of each article equals 2 times 6 plus 3 equals 15 rupees. Exercise 4.3 page 87. 1. Find the roots of the following quadratic equations, if they exist, by the method of completing the square. I, 2x7x plus 3 equals 0. E, 2x plus x4 equals 0. E, 4x plus 4 square root 3x plus 3 equals 0. IV, 2x plus x plus 4 equals 0. Solutions. I, 2x7 x plus 3 equals 0. 2x7 x equals 3. Dividing by 2 on both sides, we get x minus 7x, 2 equals minus 3 halves. x2 times x times 7 quarters equals minus 3 halves. On adding 7 quarters to both sides of the equation, we get x minus 2 times x times 7 quarters plus 7 quarters equals 7 quarters minus 3 halves. By 7 quarters equals 49 sixteenths, 3 halves. By 7 quarters equals 25 sixteenths. By 7 quarters equals plus or minus 5 quarters. X equals 7 quarters plus or minus 5 quarters. X equals 7 quarters plus 5 quarters, or x equals 7 quarters to 5 quarters. X equals 12 quarters, or x equals 2 quarters. X equals 3, or x equals 1 half. E, 2x plus x4 equals 0. 2x plus x equals 4. Dividing both sides of the equation by 2, we get x plus x, 2 equals 2. Now on adding 1 quarter to both sides of the equation, we get x plus 2 times x times 1 quarter plus 1 quarter equals 2 plus 1 quarter. X plus 1 quarter equals 33 sixteenths. X plus 1 quarter equals plus or minus square root 33 quarters. X equals plus or minus square root 33 quarters to 1 quarter. X equals plus or minus square root 33 to 1, 4. Therefore, either x equals square root 33 to 1, 4, or x equals square root 33 to 1, 4. E, 4x plus 4 square root 3x plus 3 equals 0. Converting the equation into a plus 2ab plus b form, we get 2x plus 2 times 2x times square root 3 plus square root 3 equals 0. 2x plus square root 3 equals 0. 2x plus square root 3 equals 0, and 2x plus square root 3 equals 0. Therefore, either x equals square root 3 halves, or x equals square root 3 halves. IV, 2x plus x plus 4 equals 0. 2x plus x equals minus 4. Dividing both sides of the equation by 2, we get x plus 1 half x equals 2. X plus 2 times x times 1 quarter equals minus 2. By adding 1 quarter to both sides of the equation, we get x plus 2 times x times 1 quarter plus 1 quarter equals 1 quarter, 2. X plus 1 quarter equals 1/16, 2. X plus 1 quarter equals minus 31/16. As we know, the square of numbers cannot be negative. Therefore, there is no real root for the given equation. 2x plus 4 equals 0. 2. Find the roots of the quadratic equations given in Q.1 above by applying the quadratic formula. I. 2x 7x plus 3 equals 0. On comparing the given equation with x plus bx plus c equals 0, we get a equals 2, b equals minus 7 and c equals 3. By using the quadratic formula, we get x equals 7 plus or minus square root 49 to 24, 4. X equals 7 plus or minus square root 25, 4. X equals 7 plus or minus 5, 4. X equals 7 plus 5, 4 or x equals 7 to 5, 4. X equals 12 quarters or 2 quarters. Therefore x equals 3 or 1 half. 2x plus x4 equals 0. On comparing the given equation with x plus bx plus c equals 0, we get a equals 2, b equals 1 and c equals minus 4. By using the quadratic formula, we get x equals minus 1 plus or minus square root 1 plus 32, 4. X equals minus 1 plus or minus square root 33, 4. Therefore x equals minus 1 plus square root 33, 4 or x equals minus 1 square root 33, 4. 4x plus 4 square root 3x plus 3 equals 0. On comparing the given equation with x plus bx plus c equals 0, we get a equals 4, b equals 4 square root 3 and c equals 3. By using the quadratic formula, we get x equals minus 4 square root 3 plus or minus square root 48 to 48, 8. X equals minus 4 square root 3 plus or minus 0, 8. Therefore x equals square root 3 halves or x equals square root 3 halves. IV 2x plus x plus 4 equals 0. On comparing the given equation with x plus bx plus c equals 0, we get a equals 2, b equals 1 and c equals 4. By using the quadratic formula, we get x equals minus 1 plus or minus square root 1 to 32, 4. X equals minus 1 plus or minus square root minus 31, 4. As we know, the square of a number can never be negative. Therefore, there is no real solution for the given equation. 3. Find the roots of the following equations. I, x1, x equals 3, x does not equal 0. 1, x plus 4, 1, x7 equals 11/30, x equals minus 4, 7. Solution. I, x1, x equals 3. x3 times minus 1 equals 0. On comparing the given equation with x plus bx plus c equals 0, we get a equals 1, b equals minus 3 and c equals minus 1. By using the quadratic formula, we get x equals 3 plus or minus square root 9 plus 4, 2. X equals 3 plus or minus square root 13, 2. Therefore x equals 3 plus square root 13, 2 or x equals 3 square root 13, 2. 1, x plus 4, 1, x7 equals 11/30. x7 x minus 4, x plus 4, x7 equals 11/30. Minus 11 x plus 4 x7 equals 11/30. X plus 4 x7 equals minus 30. x3 x28 equals 30. x3 x plus 2 equals 0. We can solve this equation by factorization method now. x2 x plus 2 equals 0. x2 1 x2 equals 0. x2 x1 equals 0. X equals 1 or 2. 4. The sum of the reciprocals of Raymond's age, in years, 3 years ago and 5 years from now is 1/3. Find his present age. Solution. Let us say the present age of Rahman is x years. 3 years ago, Raymond's age was x3 years. 5 years after, his age will be x plus 5 years. Given the sum of the reciprocals of Raymond's ages 3 years ago and after 5 years is equal to 1/3. Therefore 1, x3 plus 1, x5 equals 1/3. X plus 5 plus x3, x plus 5 equals 1/3. 2x plus 2, x3, x plus 5 equals 1/3. 3, 2x plus 2 equals x3, x plus 5. 6x plus 6 equals x plus 2x 15. x4 x21 equals 0. x7 x plus 3 x21 equals 0. x7 plus 3 x7 equals 0. x7 x plus 3 equals 0. X equals 7 minus 3. As we know, age cannot be negative. Therefore, Raman's present age is 7 years. 5. In a class test, the sum of Shefali's marks in mathematics and English is 30. Had she got 2 marks more in mathematics and 3 marks less in English, the product of their marks would have been 210. Find her marks in the 2 subjects. Solution. Let us say the marks of Shefali in maths be x. Then, the marks in English will be 30x. As per the given question, x plus 2, 30x3 equals 210. X plus 2, 27x equals 210. X plus 25x plus 54 equals 210. X 25x plus 156 equals 0. X 12x 13x plus 156 equals 0. X 12 minus 13 x 12 equals 0. X 12 x 13 equals 0. X equals 12, 13. Therefore, if the marks in maths are 12, then marks in English will be 30 minus 12 equals 18, and if the marks in maths are 13, then marks in English will be 30 minus 13 equals 17. 6. The diagonal of a rectangular field is 60 meters more than the shorter side. If the longer side is 30 meters more than the shorter side, find the sides of the field. Solution. Let us say the shorter side of the rectangle is xm. Then, larger side of the rectangle equals x plus 3om. As given, the length of the diagonal is equals x plus 30 meters. Therefore, x plus 3o equals x plus 6o. X plus 9o plus 60x equals x plus 3600 plus 120x. x 60 x 2700 equals 0. X 90 x plus 30 x 2700 equals 0. X 90 plus 30 x minus 90 equals 0. X 90 x plus 30 equals 0. X equals 90 minus 30. However, the side of the field cannot be negative. Therefore, the length of the shorter side will be 90 meters. And the length of the larger side will be 90 plus 30 m equals 120 meters. 7. The difference of the squares of two numbers is 180. The square of the smaller number is 8 times the larger number. Find the two numbers. Solution. Let us say the larger and smaller number be x and y, respectively. As per the question given, xy equals 180 and y equals 8x. x8x equals 180. x8x 180 equals 0. x18x plus 10x 180 equals 0. x 18 plus 10 x18 equals 0.